So this is the famous meteor crater in Arizona. I got approximately 26,000 years old here. I don't know if that's correct. Most of the estimates I've seen are 40 to 50,000 years. I think there have been some studies suggesting it's a little younger, though, like at the age I've got here. The age is not so important right now. The main thing is to understand is that this was created by the impact of an iron object. So interestingly, it was about the same size as the Tunguska object. So it kind of gives us a means of comparison. And of course, the difference being the much greater density of the meteor crater in Arizona, that meteorite is why it hit the ground and created this hole in the ground that's just obvious to anybody, and why Tunguska did not create a hole in the ground like this. So estimates here were about 20 megatons. So given that the estimate for the Tunguska, I used 15 megatons because that's the one usually cited, but there have been estimates up to 30 megatons for the total energy released by the Tunguska event. I think most of the estimates that I've seen range from around 12 to up to 30 megatons. I kind of stayed the more conservative side, which is 15 megatons, which I think is closer to the majority of the estimates, but certainly it gives some idea, gives one the idea of the destructions involved. So we're going to just run through here looking at just a gallery of some various impact craters, along with some sense of the energies released. So Lonar, India has a lake in it, about 500,000 years old. It's 1.1 miles in diameter, so that's certainly bigger than the meteor crater, which was the one we just looked at, which is 3/5 of a mile in diameter. So this is just roughly about twice the diameter. And I've got there 20 megatons, which is actually on the conservative side. It might be closer to 25 or even 30 megatons. That happens to be about roughly 1,400 Hiroshima-sized atomic bombs exploding at once, just to give you some sense of the power. This is in Ontario, Holaford crater. Now, this one is very obscure. It's almost more of an astrobleem than a crater because it's definitely a scar, but it's healed a long ways because it's obviously become eroded, infilled with sediment. But you can certainly see the circularity of it. And it's a very old one, so that's consistent with its degree of erosion. As it says here, diameter 1.46 miles. At that point, the explosive energy is about 42 megatons. So now we're getting up into the range of Tsar-Bomba, which I remember I said was 55 megatons, which was the largest hydrogen nuclear bomb ever tested during the Cold War by the Soviet Union, which was more than 3 times the power of Bravo, which was the U.S.'s largest hydrogen bomb. 2,800 Hiroshima-sized atomic bombs exploding at once. Australia, this is a really old one, diameter about 2 miles. So this is like, again, a scar, an impact scar, an astrobleem. Astrobleem literally translates as star wound. So we're up to about 125 megatons for one that size. The BP structure in Libya, which is about 120 million years old. It's almost 2 miles in diameter. So it's going to be about 125 megatons, right in that range. Some of these are old. Here's a better shot of the same BP structure, maybe with some recalculations, because probably the other one was an older version, because I've been putting these things together maybe for 25 years. So sometimes I update them, and then other times I don't update them, and some of the information may have become updated in the process but the point here is not the precise details of this, but in this case, what we're looking at is to try to get a general concept of the energies involved. I've always been fond of this. Steine Basin in Germany, about 14.8 million years old, 2 miles in diameter. There's actually 2 villages built right inside the crater. And notice the flatness of it in the farmland, which shows that the crater has been infilled with a lot of sediment. So this would have been roughly about 8,000 Hiroshima bombs exploding at one time. We come up Brent Crater in central Ontario. also about 2 miles in diameter. Now, a lot of craters in Canada, and I think one reason for that is that because of the successive glaciations over Canada, a lot of the upper layers of the bedrock have been scraped away. And so they've kind of exposed some of the astroblemes that might otherwise be more obscured under the top layers of rock. And you'll notice that a lot of them do have lakes in them. And here you can very clearly see the circularity. And this is probably the inner part of the crater. There may have been a raised rim around here. Chubb crater in northern Quebec, also about 2 miles in diameter, and it's an almost perfectly circular lake. This is Flint Creek structure in Tennessee, which is kind of in our backyard. And this is probably one of the 34th parallel chain of craters, which we're going to look at and talk about in detail, because right across from east to west in the mid-central region of the United States, there's an interesting array of craters and crypto explosion structures that are almost aligned in a pattern. Some of them are proven to be impact. Now, this is the Flint Creek structure, and this is just a digital elevation model, but very clearly the central uplift peak shows up. The rim is highly distorted, probably because of tectonic processes, because it's a very old, about 360 million years old, 2.2 miles in diameter, 180 megatons or 12,000 Hiroshima-sized bombs. Goat Paddock in Western Australia, imprecisely dated, less than 50 million years old. Now we're up to 3 miles in diameter, explosive energy about 500 megatons. So we're getting up into some serious energy here now. 500 megaton explosion, we could consider that a state killer. An object like that striking the center of Texas is going to be pretty much leave most of Texas depopulated in the aftermath. Gow Crater, Saskatchewan, 3 miles in diameter. This remnant of the central uplift is an island. Notice how the rim has been so obscured and eroded. Well, for two reasons for that. One, the glaciation itself, and then the rapid melting of the glacier and very vigorous meltwater currents also contributing to further extreme erosion. But the feature is still there, and it can actually be roughly dated, but it's less than 250 million years old. So Pilot Crater, Northwest Territories, again, we're looking at Canada, 3.6 miles in diameter, explosive energy, over 1,000 megatons now, 1,060 megatons. And this is based upon a simple formula that only gives you approximately a ballpark idea of the energies. And it's basically a formula that's derived from known impacts and nuclear explosion energy released, craters produced, etc., to come up with a simple ratio between crater size and impact energies. But of course, there's a lot of variability in there, depending on the nature of the impactor, its velocity, the nature of the target material, and so on. So this is only just a rough approximation, but it does give you the idea. It gets you in the ballpark. Decaturville, Missouri, diameter 4 miles. That puts us up there again in that 1,000 plus megatons. The Decaturville, Missouri structure is also one of these 34th parallel crater chain that we're going to look at in more detail. Brad and I have actually visited several of those. I think maybe even 3 of them, of the 9 or 10 of them. Crooked Creek, Missouri. This is another one that could be possibly related to this crater chain. It's 4.34 miles in diameter. Check this out, 1,792 megatons. So that's 120,000 Hiroshima bombs all exploding at once. So we're getting up to some pretty significant energies. Another one, Couture, Quebec, Canada, 5 miles in diameter. At 5 miles now, we're up to 2,800 megatons. Let's move on, because this is Bagash, I don't know, Kazakhstan, approximately 5 million years old, 5 miles. So here's 2,800 megatons again. We'll keep going. Shoemaker, Australia, named after Eugene Shoemaker, who was studying this particular crater when he was killed in a bizarre accident in the outback of Australia. And I don't have the size of this, so let's see, I might have it. No, don't have it. So, but it doesn't matter. La Moyniere, Quebec, 400 plus or minus 50 million years, 5 miles in diameter, 2,820 megatons. Keep going. This is Upheaval Dome, Utah, less than 65 million years old, 6 miles in diameter, explosive energy. Now we're up to about 6,000 megatons. Remember, I said that the peak of the Cold War, the total nuclear arsenals of the U.S. and the Soviet Union was 10, maybe 12,000 megatons. That was considered to be pretty much enough to destroy the world if it was all unleashed in a nuclear
scenario.
exchange, right? So Brad and I actually visited this one. It's pretty impressive because it's an astrobleem that was undoubtedly buried and has had the top layers of rock stripped away to expose this thing that was, at one time buried beneath the surface of the land. And you see remnants of the old land surface around it in the rim. Look at this central uplift here. So this would be a really cool expedition. In fact, we would add this to the list in one of our undoubtedly future expeditions into the Colorado Plateau and Canyonlands area, because this is in it's in Canyonlands, right, Brad?
Yeah, that's what I was going to add there. That's the Green River right up at the top. So that is within the Canyonlands National Park in Utah, southern Utah.
Right. Sweet. Okay. Eagle Butte. This one's hard to see, but I put in a circle. Again, a lot of these are really obscure, and from the ground, you wouldn't even know they're there. So this is more like an astrobleem rather than a crater, because the scar is still there. And then you do the studies and you find all the impact proxy material, or you find shocked quartz, or you find brecciated rock, which is broken rock, or you might find some melt glass. Many of the different various ways that craters are identified and confirmed. So check this out, 6 miles, 5,300 megatons. Basumtwi in Africa, 6.5 miles, over 7,000 megatons. Now Deep Bay, Saskatchewan, diameter 7.2 miles. Notice 9,950 megatons. So we're now getting up close to the total megatonnage in the arsenals of the superpowers during the peak of the Cold War, which thankfully never got unleashed in an all-out thermonuclear war, or we would probably not be having this congenial conversation right now. So as you can see here, now we're getting up in the scale. This thing is, like it says here, 7.2 miles in diameter. Here's one in Brazil, also about 7.2 miles in diameter, so the energies would have been equivalent. Zhamanshin, Kazakhstan. This is young, less than 1 million years old, 8.7 miles. Notice here, 18,900 megatons. So now we have exceeded, and this thing, if you can see it, it's right in here. Let's see, I might have it. No, I don't. But so now we're well beyond the total megatonnage of the entire nuclear arsenals.
So less than 1 million years ago, there was an event there that released more than the entire megatonnage of the Cold War arsenal. That's
all being exploded at once
in the same place.
Yes.
Kazakhstan.
In
Kazakhstan. Yes. So you can see that would have been a pretty significant event. So it'd be interesting to look and see if there's any evidence of, extreme sudden climate change in this area, any mass extinction events, any biotic turnovers, which I haven't done, but of course it'd be interesting to look, because I would think that an 18,900 megaton explosion would have to have some kind of substantial effects that would leave residuals that could be studied today. Wells Creek, Tennessee. We also visited this one, and there is there's a quarry we didn't get into, but there's a quarry. I think didn't we learn in the Central Uplift, Brad? We met the gentleman who had property adjacent to the roadway into the quarry. Was Wells Creek, wasn't it?
I don't think it was right in the Central Uplift.
Okay.
I think that's the Tennessee River coming across there right at the top.
Yeah. So we didn't get in there. So that's probably worth a return trip at some time. It would be really interesting to get into that quarry. We did get into the quarry and took a tour of the quarry in the Kentland impact structure in Indiana. And that was really interesting, especially because you could really see the uplifted rocks and the very prominent and impressive shatter cones.
Oh, yeah.
A quarry or a mine?
A quarry.
Okay.
Like a surface open pit quarry that's basically, extracting rock and gravel and things.
Yeah. Okay.
Yeah. Spider Crater, 8 miles, energy 14,710 megatons. And here we go. Texas, Sierra Madera. That's a big one. 8 miles in diameter. Less than 100 million. How much less? I don't know. Maybe since I did this is an old program I did. I'm probably going back 12, 15 years ago. But there's maybe a lot of updated information that could be incorporated into this. But at this point, again, it's not so much the exact specifics, but at least to get kind of a general idea, a general comprehension of it.
I've driven through that one.
You have driven through that, huh?
Yes, and there is mining stuff at the central uplift. You can see all the equipment.
Ooh, interesting. I wonder if they could be contacted and we could go in it, because that's what we did. We contacted the quarry owners or maybe we just drove on in and asked them if they would, and they were happy to give us a tour. We all put on our hard hats and down we went.
Yeah, that would be great.
Yeah.
Oh yeah,
they can be contacted. Just don't be trespassing on the property.
Ames, Oklahoma. Look at there, 10 miles in diameter. Some of these, of course, are just terrain modeled because they don't really show up too clearly from the surface. But again, a lot of research is ongoing, and I haven't been able to keep up with the most, up-to-date information on all of this. 10 miles in diameter is now 29,800. So we're close to 30,000 megatons. So now this object here, explosion, we're getting, in the range of 3 times the entire nuclear arsenal. Arunga, Chad, this one I've always thought was quite interesting. 10.2 miles, 36,600 megatons. That's 2.4 million Hiroshima bombs going off at once. This astrobleem is part of a multiple impact event. It looks like that there's another right up here. You can see it in the upper right-hand corner. And then above that, there appears to be even a third impact scar. So this could have been an object that was coming in fragmented, probably an early fragmentation, and in the sense that it hadn't had much time for the parts, the 3 objects, if they were in fact that they were originally one object, for them to become separated very far. I've never really known how to pronounce How would you say this, Kyle?
Yeah, I think you had it right. El-Jijitin.
Yeah, El-Jijitin, Russia. Okay. Yeah. So, yeah, getting up there, Gosses Bluff, Australia, 14 miles in diameter. And here you see a central uplift ring, which I think is interesting. And Rees, Germany, 14.4 miles, less than 15 million years old. So that puts it back early Pliocene. I heard a sound. Hot and Astrobleem, Northwest Territories, 7.9 million. We'll just skim through these. Notice you're up to 20 miles here in diameter here. Explosive energy, 200,000 megatons. Now we're getting into a serious global event with the ones that are following. 20 miles. So we're looking, here we go, Shoemaker. Approximately 20 miles, less than 5 million years.
Only 5 million?
Yes.
Wow.
Which is interesting because notice I've mentioned before the Hemphillian extinction that was about 5 million years ago. I was saying that, if you look at the late Pleistocene extinction and then you go back in time to find an equivalent extinction level event, you're back at the Hemphillian, as it's called, and that's usually dated at about 5 million years. Is there a connection? I don't know. Maybe it's just a coincidence, but maybe there is a connection. 17.5 miles, 200,000 megatons. And then we get to Clearwater Lakes. This one's always been fascinating to me. This is like a tandem or a dual impact. Two objects. Are they simultaneous in impact time, or are they separated in time? I don't know the answer to that. I think most of the assumptions are that it was like a twin object that they impacted simultaneous. There may be new studies on it showing that were not exactly simultaneous. I don't know. But notice here, West Crater over here, which has a central uplift ring, is 19.2 miles in diameter, and the Eastern Crater is 13.2. The combined explosive energy, 400,000 megatons.
So that's like the size of the Hiawatha right there, that 19.2 miles.
Yeah. Now, we are now looking at certainly global scale event here. Maybe not enough to cause the kind of mass extinction we saw at the KT or Permian Triassic boundaries, but certainly enough to have global ramifications. Carswell, Saskatchewan, 23.5 miles, over 600,000 megatons. Here's one in Araguaia, Brazil, 25 miles in diameter. Karakul in Tajikistan, again, notice here, 5 million years old. So is it possible we're looking at a bombardment period? 28 miles in diameter. So again, here's two major craters on different sides of the Earth coinciding roughly with a mass extinction level event. Are they connected? I don't know, because I would have to really go in and get a very accurate chronology in order to try to tie these together. But what we're seeing here within the broad parameters, it certainly opens that possibility that we had a period, and they may have not occurred at the same time, but the thing is just, if you have one blow that incapacitates a large section of the planetary biosphere, and before it can fully recover, you have another one or several more. You see, it may not be just one punch that takes it down. It may be several, you see. Siljan, Sweden, 31.2 miles. Look at that explosive energy. Now we're looking at 1,640,000 megatons. Now, again, global event, but very old. Ackerman, Australia, again, very old, but global, 34 miles. You don't have an explosion that unleashes 1,800,000 megatons without having global consequences. Charlevoix, Quebec, 34 miles in diameter. Beaverhead.
Randall,
yes,
you're looking at these ultra large scale asteroids, and you keep saying global consequences. Give us an idea what those global consequences would be for something like this.
Well, you'd have darkening of the skies. You'd probably have intense acid rain. You'd have, large scale regional biomass burning. You'd probably have seismic consequences and perhaps volcanic consequences, because, this is going to, even the Tunguska event caused, detectable changes in Earth's magnetic field that lasted for hours, right? I mean, we're really just at the beginning of understanding how these things are going to affect. But yeah, certainly it's going to affect the Earth's geomagnetic field. It's probably going to strip away the ozone layer, which allows a lot more cosmic radiation to come in, and which could produce mutational episodes. I mean, there's all kinds of things that could happen. Now, obviously, in the immediate vicinity, it's going to wipe everything out. It's going to sterilize that section of the planet. In other areas, the effects will be less severe, but there will certainly be consequences. You can't have, like it says here, a 2,666,000 megaton explosion without there being global consequences.
Are they extinction level events?
Well, okay, now when we're getting up to Manicouagan, look at here. Yes, I think now we're getting at extinction level events. Now, can we correlate? There has been some attempt to correlate Manicouagan, I think, with the Jurassic extinction event, but I think at this point the dating is not strong enough to show a definite correlation. But even without a definite correlation, my thought is that an event like this that could produce a 50-plus mile diameter crater could have effects that would take millennia to play out. I mean, it could cause instabilities in the biosphere, in the lithosphere, even in the internal areas of the core. The idea of what happens. We didn't talk about this episode, but we'll talk about it coming up. The possible Yellowstone hotspot being a result of an impact, that by striking the Earth and causing a very deep event, you're releasing the magma from down deep into the lithosphere that is now rising up in a plume to the surface. David Alt has done some work on that, and we'll get into that, especially when we come around to setting up the context for the Great Pacific Northwest mega flood events, which will be coming up. Manicouagan, as you can see, over 7 million megatons. So obviously an event like this is going to destroy everything. Now, an event like this would probably, let's say if it happened in the Western United States, would pretty much wipe out an area the size of the entire Western United States. You'd have fallback debris that, if you had forests, would ignite secondary fires. That's part of it. The amount of dust and soot and stuff injected into the atmosphere is going to be, I mean, we know just from the eruption of Pinatubo that, that amount of dust entered into the atmosphere has global climatic effects. So clearly there would have to be climatic effects, undoubtedly cooling.
Yeah, the cooling, and then of course you'd have crop failure and habitat loss and all of the above. And so people, you could have bottlenecks in many different, if not full extinctions. And
a bottleneck might not show up. See, that's the thing about the late Pleistocene, like particularly amongst humans, because if you may reduce the human population by 90%. But if that other 10% that survives is pretty much genetically diversified, you may not catch a bottleneck, if you're not looking for it. Chesapeake Bay astrobleme, this is 56 miles in diameter. This is the one that created the tektite field that shows up in Georgia. So we're going to wrap this part of it up. Here's of course, the famous, this is again buried under nearly half a kilometer of limestone. But what's under there is this thing, a multi-ring structure with a central uplift. Its estimated explosive energy is 300 million megatons. And of course, this is the extinction level event and impact associated with the rapid disappearance of the dinosaurs at the end of the Cretaceous. And then you have the Sudbury, Ontario, 155 miles in diameter, 340 million megatons. Again, we're talking about a global event. The Vredefort structure in South Africa, 187 miles in diameter. So these are huge events, and thankfully they were a long time ago. But, we might be talking here about a different class of events that Brad mentioned earlier, that if we look at, say, a Tunguska type event. Now, if one of those happened over a densely populated urban area today, you're talking about instantaneously 1 million casualties. Okay, so that would be global event, and certainly in the sense that it would have global economic repercussions. It wouldn't necessarily, if it happened, let's say, over the eastern seaboard, it's not going to have consequences, ecological or climatological consequences too much for, say, somebody in Europe. But if you instantly wipe out an entire city the size of Washington, D.C. or New York, and you kill 1 million people and perhaps leave another 2 or 3 million people really seriously injured, that's going to have all kinds of consequences, social and economic. But here's what we're going to get at, and here's what we're going to see, particularly when we come back to talking about the Younger Dryas, and the idea that if you're only limited to crater counting, you may not really be looking at the full broad picture of the kinds of things that would threaten human civilization. Because we are finding that there's evidence for what we could say is multiple simultaneous Tunguska events. In other words, Tunguska was one perhaps piece of a probably spalled off of Comet Encke. Encke was probably spalled off of a much bigger object that might have been 50 to 100 miles in diameter that came into the inner solar system and began this ping pong between Jupiter and the sun. And during that process begins to disintegrate. Now, is it possible that Earth encountered the byproducts of that disintegration more than once? Well, certainly it is, because the Earth crosses that stream twice each year, right? So what we have to begin looking at, and this is what Chandra Wickramasinghe has addressed, Fred Hoyle, Victor Klube, William Napier, William Asher, all of these guys, what they're looking at is the dangers posed by a multiple Tunguska type event, where you might, what if you had a dozen Tunguska objects coming in? Or 100? What would 100? Well, now we're looking at an event that would be on the scale of a thermonuclear war. 100 Tunguskas, my God, that would be, you start contemplating the consequences of that, and they would be profound. Probably not enough to cause a mass extinction event that somebody 100,000 or a million years from now could come along and document. But certainly the consequences for the stability of modern civilization would be severely tested. Even maybe to the point where civilization itself would collapse. And see, what these guys are looking at is amassing evidence that makes that a very realistic scenario. See, so it may be that just our crater counting doesn't really give us the full picture, because that is a specific class of objects. You got 100 Tunguskas coming in, and they're exploding in the atmosphere because, let's say, they're between 30 meters and 100 meters in diameter. Well, you're going to have some very serious surface consequences, but you're not going to have craters produced per se. All right, so we'll keep going here. We've seen some of this, so I'm not going to dwell on this. This is Upheaval Dome in Utah, Manicouagan, KT boundary. We've seen all that. Okay, so now we've got the map of confirmed and probable impact structures and astrobleams. This is really what it looked like a decade and a half ago. We've added to it. Now, again, what I want people to really realize and contemplate is that all of these impacts, virtually all of them are on land. There's a few, yes, we're discovering that there are a few of them on the ocean floor, but again, for every one that you see on land, there should be 3 to 4 that have struck the ocean. So we need to have a more extended conversation about the consequences of oceanic impacts, and we will. Modern science is rediscovering what our ancient ancestors knew. Periodically, planet Earth is overcome by sweeping catastrophic events that completely remodel the landscape of the world, reset the global ecological clock, and disrupt humankind's efforts to build a sustainable civilization. The forces of nature that trigger such events are still operational and will remain so despite our refusal to acknowledge them. But whether we accept it or not, we are inextricably a part of a cosmic ecosystem. And our fate is tied to phenomena which, for the time being, is beyond our ability to successfully respond. This can change, but only with a major change in our priorities as a civilization. The process begins with education. Please join us and participate remotely, as the Cosmic Summit will be live streamed to the world via howtube.com.